Using the quadratic formula to solve quadratic equations. The solution of a quadratic equation ax squared plus bx plus c equals 0 are given by the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. The quadratic formula can be used to solve any quadratic equation. When using the quadratic formula, for the fraction part in the quadratic formula, notice that the term negative b is part of the numerator. You want to be very careful about how you write this. The correct form is negative b plus or minus the square root of b squared minus 4ac all over 2a. The incorrect form is to write negative b plus or minus, then your fraction. That is to be avoided. In this example, use the quadratic formula to solve the equation. All solutions are real numbers. 5x squared plus 5x minus 1 equals 0. To use the quadratic formula, first you need to remember that ax squared plus bx plus c equals 0. That means a is 5, b is 5, c is negative 1. Then using our quadratic formula, x equals the opposite of 5, which is negative 5, plus or minus the square root of 5 squared minus 4 times 5 times negative 1. Our square root symbol should cover all of that. All of this is divided by 2 times 5. Once you've substituted into the formula, you can do the math to find x. So I have negative 5 plus or minus 5 squared is 25 plus 4 times 5 times 1 is 20 divided by 10, which is negative 5 plus or minus the square root of 45 divided by 10. Negative 5 plus or minus 45 is not a perfect square, but part of 45 is a perfect square. Since 45 is 9 times 5, for the square root of 45, I could take the square root of 9, which is 3, and leave my square root of 5, and that's divided by 10. If we were to reduce this, it's very important to remember that the 5, the 3, and the 10 all have to have something in common. So while 5 and 10 have a common factor of 5, 5, 10, and 3 do not have anything in common, so this answer cannot be reduced. So x equals negative 5 plus or minus 3 square root of 5 divided by 10, or we can write the answer as x equals negative 5 plus 3 square root of 5 divided by 10, or negative 5 minus 3 square root of 5 over 10. In this example, use the quadratic formula to solve the equation. All solutions are real numbers. 5x squared minus 4x equals 2. So we need our quadratic equation to be in the format of ax squared plus bx plus c equals 0. So the first step here is to set this equal to 0. 5x squared minus 4x minus 2 equals 0. So now I can pick out my a, which is 5, my b, which is negative 4, and my c, which is negative 2. Now I'm ready to use my quadratic formula to find x. So I bring down my x equals the opposite of negative 4, so that's a positive 4, plus or minus the square root of negative 4 squared minus 4 times a, which is 5, times c, which is negative 2. All divided by 2 times a, which is 5. So now we can do our math. So I have 4 plus or minus the square root of 16 plus 40 divided by 10, which equals 4 plus or minus the square root of 56 divided by 10. So 56 can be written as 4 times 14, 4 plus or minus the square root of 4 is 2, square root of 14 we don't know, divided by 10. So when I try to decide if I can reduce, I need to look at the 4, the 10, and the 2, not the 14. Since all three are even, I can divide 4 by 2, which gives me 2, plus or minus 2 by 2, which gives me 1, square root of 14, divided by 10 divided by 2, which is 5. So my answer is x equals 2 plus or minus the square root of 14 all over 5, or I can write my answer as 2 plus the square root of 14 divided by 5, or 2 minus the square root of 14 all over 5. And remember that this is our x value, so our x equals is important. In this example, we're going to use the quadratic formula to solve our equation 5 over 8 x squared plus 3 over 4 x equals 1/4. Now, it's going to be cumbersome to use fractions in our quadratic formula. If I were to multiply this equation by the least common multiple of 8, 4, and 4, I could get rid of my fractions. I can only do something like this when I have an equality. The smallest number that will cancel an 8 and a 4 would be 8. I would have 8 over 1 times 5 over 8 x squared plus 8 over 1 times 3 over 4 x equals 8 over 1 times 1/4. My 8's would cancel, leaving me with 5x squared plus my 8 and my 4 cancels. 2 times 3 is 6, and then my x equals my 8 and my 4 cancel, leaving me with 2 times 1, which is 2. And then getting it in the form of ax squared plus bx plus c equals 0, I would subtract the 2. So I have 5x squared plus 6x minus 2 equals 0. And now I'm ready to use my quadratic formula. So now we can find a, which is 5, b, which is -6, and c, which is -2. Substituting into our quadratic formula, x equals the opposite of -6, so +6, plus or minus the square root of b squared, so that's -6 squared, minus 4 times a, which is 5, times c, which is -2, all divided by 2 times a, which is 5. So that equals 6 plus or minus the square root. -6 squared is 36. -4 times 5 times -2 is a +40, all over 10. That equals 6 plus or minus the square root of 76 over 10. 76 is even, so calculating. So I have 76. It's even, so I'm going to divide it by 2, and I get 38. Still even, so I'm going to divide it by 2 again, and I get 19. So I can write 76 as 19 times 4. I'll be able to take the square root of 4, but not the square root of 19. So we have 6 plus or minus the square root of 4 is 2. Square root of 19 we don't know, all over 10. So that is going to reduce because 6, 2, and 10 are all even. 6 divided by 2 is 3, plus or minus 2 divided by 2 is 1, square root of 19, and 10 divided by 2 is 5. So my final answer is x equals -3 plus or minus the square root of 19 all over 5. I can also write my x value as -3 plus the square root of 19 over 5, or -3 minus the square root of 19 all over 5. In this example, find all x-intercepts. F of x equals negative 5x squared plus 3x plus 2. Because we're looking for the x-intercept, that means f of x is 0. So 0 equals negative 5x squared plus 3x plus 2. And our quadratic equation is in the format for us to find a, b, and c, and then use our quadratic formula. So a is negative 5, b is 3, and c is 2. The nice thing about the quadratic formula is it doesn't matter if your leading term is positive or negative. If I were factoring, I would need my leading term to be positive, so I'd have to factor out a negative 1. With the quadratic formula, that doesn't matter. So I'm ready to substitute. X equals the opposite of 3, so negative 3, plus or minus the square root, so 3 squared, minus 4 times negative 5 times 2, all divided by 2 times negative 5. So x equals negative 3 plus or minus the square root. 3 squared is 9, minus 4 times negative 5 times 2 is a positive 40, all over 2 times negative 5, which is negative 10. So this equals negative 3 plus or minus the square root of 49 all over negative 10. The square root of 49 is a perfect square, so I have negative 3 plus or minus 7 over negative 10. Unlike the other problems that we have done with the quadratic formula, this one can actually be simplified further. So we need to write this as x equals negative 3 plus 7 over negative 10 and negative 3 minus 7 all over negative 10. Then we simplify, so negative 3 plus 7 is 4 over negative 10. 4 over 10 reduces to negative 2/5. Now looking at negative 3 minus 7 over negative 10, negative 3 minus 7 is negative 10 divided by negative 10 reduces to 1. So my x-intercepts are negative 2/5, 0, and 1, 0. Determining the number of real number solutions. When you're deciding how you want to solve your quadratic equation, you want to try to decide what's going to be the easiest to use. Do I want to factor? Do I want to complete the square? Do I want to use the quadratic formula? To help you decide that, it's useful to know what type of solution you're going to have. For the quadratic equation ax squared plus bx plus c equals 0, the discriminant is b squared minus 4ac. Also, if b squared minus 4ac is greater than 0, that means there are two real number solutions. The two real number solutions may or may not include a square root. If b squared minus 4ac equals 0, there is one real number solution. This is going to be when you have a perfect square trinomial. If b squared minus 4ac is less than 0, then there are two imaginary solutions and no real number solutions. In this example, determine the number and type of solutions of the equation, which means we don't actually have to solve the equation. We just are trying to decide what our solutions will look like. 5x squared minus 3x plus 2 equals 0. So using the discriminant, I want b squared, so that's negative 3 squared minus 4 times a, which is 5, times c, which is 2. That equals 9 minus 4 times 5 is 20 times 2 is 40, and 9 minus 40 is negative 31. Since my 31 is negative, I have two imaginary number solutions. Example. Determine the number and type of solutions of the equation x squared plus 6x plus 9 equals 0. So using my discriminant, I want to substitute b squared. B is 6, so 6 squared minus 4 times a, which is 1, times c, which is 9. This gives me 36 minus 36, which equals 0. So I have one real number solution. In this example, use the quadratic formula to find all complex number solutions. X squared minus 3x plus 15 equals 0. I have x equals the opposite of negative 3, so that will be 3 plus or minus the square root of negative 3 squared minus 4 times a, which is 1, times c, which is 15. That's all divided by, so 2 times 1. So this gives me 3 plus or minus the square root of 9 minus 60 divided by 2, which is 3 plus or minus the square root of negative 51 over 2. So x equals 3 plus or minus I square root of 51 all over 2, which I can write as 3 plus I square root of 51 divided by 2, or 3 minus I square root of 51 all over 2. In this example, use the quadratic formula to find all complex number solutions. 2 parentheses 5x minus 2 equals negative 1. So we're going to have to do some math here to get this in our format of ax squared plus bx plus c equals 0. So first I'm going to distribute my 2x, so I have 10x squared minus 4x. Then I'm going to add 1 to both sides, plus 1 equals 0. I'm ready for my quadratic formula now, and I can substitute. X equals the opposite of negative 4, which is 4, plus or minus the square root of negative 4 squared minus 4 times 10 times 1 all over 2 times 10. This equals 4 plus or minus the square root of 16 minus 40 all over 20. 4 plus or minus the square root 16 minus 40 is negative 24 all over 20. I can simplify 24 because it is 4 times 6, and I can simplify my negative to I. So I have 4 plus or minus the square root of 4 is 2, the square root of negative 1 is I, 6 stays under the root, divided by 20. Because 4, 2, and 20 are even, I can reduce this further. 4 divided by 2 is 2, plus or minus 2 divided by 2 is 1, I, square root of 6, divided by 20 divided by 2 is 10. So my final answer is x equals 2 plus or minus I, square root of 6, all over 10. Or I can write my answer x equals 2 plus I square root of 6 over 10, or 2 minus I square root of 6 over 10. Using the quadratic formula to solve quadratic equations. Deciding which method to use to solve a quadratic equation. If our method is factoring, when to use would be for fractions that can easily be put into the form ax squared plus bx plus c equals 0, and where ax squared plus bx plus c can be easily factored. The square root property are four equations that can be easily put into the form x squared equals k or parenthesis x plus p squared equals k. Completing the square. Use when the directions require it. Quadratic formula. For all equations except those which can be easily solved by factoring or by using the square root property.